presentations?
March 30th.
March 30th, okay. This will help me get to know your names. On the 30th, who has myelogram? Myelogram?
I have myelogram.
Your name?
Asia. Asia.
Asia?
It's
All right, so you're the 30th.
okay.
Nuclear medicine.
Yes, sir.
Name?
Steven.
ERCP.
Christina.
All right, so you guys will be presenting on the 30th. Okay? Now we move to the 6th of April. Who has ultrasound? Anybody? I think it's up here. I'll just go over here. Angiography?
Mallory?
PET scan 1 and 2.
Molly, pet one.
Pet 2, Quincy? Quincy?
Quincy. So you guys will be doing a joint. Okay? MRI.
Megan.
Stevie.
Stevie. I guess that's Memo,
Mm-hmm. That's the
huh?
one.
Brianna.
Yes.
All right, so does everybody have their date?
What
Let
was
me
the-
go over
what
it
was the
again.
MRI?
On the 6th is ultrasound, angiography, Mallory, PET, Molly, and Quincy on the 6th of April, okay? On the 13th will be CT, MRI, Megan and Stevie on the 13th, and then Brianna's gonna do mammography on the 13th of April as well. All right, so you have your topic, you have your date.
Are you assigning ultrasound to one of the people that are
Yeah,
out?
they're up here, and CAT scan's up here. All right, so I'll put a name to it. Okay. So everybody has their assignment. Now here's what I'm looking for. It's a PowerPoint presentation.
I like those.
Perfect, you do. You like making them.
I do.
I actually do too.
Now here's the thing, guys. I'll put a slide up and read it.
Can we include stuff like pictures and
Well,
videos?
I'm gonna tell you.
Okay.
Yeah. All right. We're gonna get the supermodel here on this one. Yeah, PowerPoint. You can put a slide up and talk about some of the things, but don't stand here and read. You know, myelogram is done on the that is fine, but no, we're not gonna do that. Okay. For those of you in teams, 30-minute presentation. Okay, the rest, 20. All right, now, I'm going to give you the evaluation sheet. This is what you base your everything here when you look at it. Those categories on the left is how your presentation should flow. Everybody have one? I guess I should go over that a little bit. In case. All right, introduction to your topic. You need to tell your audience really what this is and what it does. A little history on the study. Give a nice, simple discussion of how it operates. Who would some of the vendors be that you would get this from? How much does it cost? And the thing that people really like, and you can find this, how about some images? Okay? Images of the study with normal and pathology. There's plenty out there.
Yeah, I can just take the whole thing over.
Don't be putting that up there.
Okay.
And then I'm going to evaluate you on time. Okay, the time of your presentation. And you know, oh, I'm running. I'm going to finish early. You know what? Throw some questions in, generate a discussion. If you need to.
Will you tell us when we hit 20 minutes? Or...
Oh, I'll be back there waving.
Oh, okay.
Yeah, oh yeah. You concerned you'll go over?
No, no.
Oh,
A little
okay.
under.
All right. So yeah, I think there's flexibility in this as long as you cover it.
You can start to present how it's done.
Yeah.
Totally.
When I start doing research, will there be an obvious difference between PET 1 and PET 2?
Pet person 1, pet person 2. That's it. There's
Same
2 of you.
information, just
Yeah.
making sure we're not copying each other.
Oh yeah, you don't want to do that. And you know what students have done in the past, you know, they'll divide it up, you know. I mean, I've done group presentations too.
So for the PET, do we do the same presentation together, or do we have an individual presentation per person? Or
No,
is it
it's joint, it's a team.
It's a team,
Yeah,
okay.
yeah, yeah. Mhm. However you guys want to divide it up is fine. You know, if you want to do tag team back and forth is fine, or somebody does the first half, somebody does the second half.
There must be a lot of information on this.
Well, you know, it's a big subject. There's going to be 2 teams. It's what PET and MRI. All right. Now, and then there's the other one here. Special considerations. You know, what does this imaging modality that you're studying need for like room preparation and things of that nature? Because some of the, you know, MRI, you probably aren't aware of it, but that involves a lot of room preparation.
So you're not grading at all what the presentation looks like, just what we say.
Well, yeah, you know, I don't want a bunch of slides that are crooked or.
My creative ability.
Oh, here's another thing too, guys. Here's another thing too. You've seen this. People make PowerPoint slides and they're crowded. Too much information. Don't do that. Little print. No. Yeah. Make it,
Simple.
make the reader want to read it. You know, not too much. I would say in this case, what less is better. Yeah.
We could do like bullet points and then you can speak on the bullet points.
Yep. Mm-hmm.
What if we made it just pictures and we just explained off of that? Or
You
do
can
want
do
it to
that.
have words?
Yeah, I don't need type.
Okay, okay.
Special consideration, what does this need? Anything else?
On March 23rd, image intensification?
Yep.
What's that about? What's that?
All right, I'll tell you what that is. It's an imaging procedure. Now, when you were young, you watched cartoons? And no doubt you've seen the piece on the cartoon where somebody swallowed a fish. Okay? And they put him behind a screen and they showed the fish doing what?
Swimming.
Swimming. Roughly, that's what image intensification is. It's imaging that's dynamic. In other words, there's motion. It's live. It's ongoing. Okay? So, like, for instance, where would we use that? Yes?
Question, do you need a reference page?
No. We're not going to publish this. Did I answer your question?
Oh, thanks.
Yeah, it's imaging in motion.
My least favorite part about writing essays, the reference page, you're off by a period, there you go, never mind, 20 points. Like, okay.
When you got to annotate, you know, go to the end.
So I don't see anything in here for midterm or final exam.
I did one exam. I don't retest.
Oh, so exam 4 is like the final or whatever?
Exam 4 is the exam 4.
So the last grade will be our presentation then.
Yeah, and of course participation.
What is, it says 0420 open, what does that mean?
In case we're behind.
On the presentation.
Or you know, on anything. If we run late. If that's our what's the word I'm looking for? Back up. A cushion.
So if we have questions on this at any time, we would just email you?
Yeah, you can. Exam.
26th of January.
Be 2 weeks. So we're going to do some lecture now. We'll come back next week and do some lecture again. And then what we'll review and then what the test is the next Tuesday. That's kind of how this works up to the presentations.
Are your tests pretty much the same, all, like 1, 2, 3, and 4 are all pretty much the same format, or is it just?
25 questions, multiple choice, true, false. I use Scantrons. You guys you don't like it?
It's just been a while.
Oh, really?
Yeah, Scantrons.
Is that,
I don't know.
you like the short answer, do you? You like to do that? What would be your definition of matter?
Something that has weight.
Anything that takes
Takes
up
up space.
Yep,
Space.
anything that exists and has a physical property and occupies space. A principal characteristic of matter is something called mass. which is a quantity of matter. And it's measured in kilograms. Which is, what do you understand a kilogram to be? Just, what is it? Well, is it length?
It's a weight.
It's weight. Yeah, it's weight. Very good. Okay, moving along. We're going to get to this here pretty soon. You all know what this is? No? Yes?
Yes.
Did you ever watch that show? Because I have to, when I talk, I have to. The Big Bang Theory,
Yeah.
Sometimes.
one of the early episodes, it still cracks me up. Their shower curtain had this on it. Somebody was clever, okay? Okay, energy. Now, you all know about something called a linear accelerator, right? That produces radiation. That's a form of energy. It comes under the category of electromagnetic radiation. Which is a what?
Wave.
A wave. Very good. You'll need to know the law of conservation of energy. Which is the sum total of all matter and energy in the universe is constant.
So, you repeat that one more time.
Sure. The sum total of all matter and energy in the universe is constant. Matter and energy cannot be created or destroyed but can be converted from one form to another. All right, so let's talk about that for a minute. Your linear accelerator, your projects, your machines, okay? What do we start out with fundamentally before it even goes into this machine? They all need what?
Power,
Okay, let's break that down to power.
energy, electricity.
Electricity, right? It's electricity. It goes into these machines, and guess what happens? It gets changed around from one form to another. Okay? And you ask about image intensification. When we cover that, you will see all the different forms of energy along the way that an image intensifier uses, okay, to create, in the end, an image. So that's the greatest thing about this. I mean, just think about in your homes, right? Do you all know in your in your neighborhoods or behind a public building? You know where I'm going here, anybody? Shout it out.
Retention ponds, or,
The what? Retention ponds?
I mean, that's behind workload, I didn't.
It is. Yeah, it is. All right, it looks like this. Sits on a cement slab.
I know what you're talking about, but I don't know.
Transformer?
Who said that?
That's home.
Yeah, it's called a transformer. Okay, you've seen them?
And my
In
daughter
your
jumps off of
They're
it.
like
Your what?
green.
My daughter jumps off of it.
Does she?
Yep.
Okay.
Used to hang.
That's a transformer? I thought the transformers are up on the poles.
But
Where
there was,
Those are
okay,
small.
they can be up on poles, they can even be in the ground, but you don't want them to get wet. Okay, and so what goes into a transformer?
Electricity.
Okay, I'll draw it. I'm not an illustrator. The students tell me you're not the best, and you know, I know that, but I get my point. Tell me what I'm drawing here.
Power lines,
What kind?
high power.
Yeah, they're called high voltage power lines. Okay, why?
They're carrying high voltage.
They carry high voltage. That's what comes from the power plant. High voltage, low MA. Why do they do? And they can control that at the power plant. So it's high voltage, low amperage. That's how it's transmitted from the power plant into those lines. And why is it transmitted that way? Because this creates the least heat.
What does amperage mean again?
Amperage is like the flow of current, okay? The pace
How fast it's.
that it flows. You know, like when you go home and you run the coffee maker, the dryer, what else? All your appliances, things are moving pretty fast. Creates a lot of what?
Well,
Yeah, and heat, and what happens? Something shuts off, doesn't it?
Breaker.
Yeah, the breaker shuts down. So look, wait a minute. This is way too much heat. This could be unsafe. I'm shutting down. So what these high voltage goes into this, the what? Transformer, and it steps that high voltage down. Okay, it's not high voltage anymore. If they step it down, something come in your house. Okay,
It's not dangerous at all for it to be on the ground.
apparently not. You know, you don't want to hit it with a car, right? You know, you've probably experienced that, yeah. So you step it down to a voltage that you can work with in your home. Same for your linear accelerator and your equipment. It has to have a voltage. The voltage is what? The pop, right? The smack, the zap, okay? The drive. You know, and that's what, you know, it's incredible that.
So the voltage is the amount of energy.
Yeah, the bird can sit on those things.
I
That's it.
said, what the
Huh? Yeah.
heck?
What?
I was about to say,
So the voltage is how much energy is traveling, and amperage is how fast it's traveling?
Yeah, yeah, how fast, but and the voltage is the snap, the pop, the drive. Okay? You know, like those little 9-volt batteries aren't going to start your car, right? So you need a certain voltage to get it going. Okay. But you will see as you go through your presentation, just be mindful. It's going to be one form of energy to another. You know, if we didn't have that, we wouldn't be able to do a lot of what we do. I mean, when you look at your linear accelerator, it was electricity. When you give it to the patient, it's what?
Radiation.
It's a wave, isn't it? Yeah. Okay. Now, when you hear this word, I'm gonna look back here. What do you think of?
Protons, neutrons, and electrons.
Oh. Protons,
Protons,
neutrons.
neutrons, electrons.
All right. I didn't have to say a thing. Atomic theory, atomic structure.
That work, that work. I can't believe they just give you a bad marker like that.
Let's see what's in the drawer. Well, at least I have one.
I just.
Okay, atomic theory. I'll do one more. What would this be?
Nucleus.
And what lives in the nucleus?
Protons and neutrons.
All right. What are these called?
Valence shell,
Shells. Who lives in the shell?
electrons.
So smart.
And there's a limit on how many electrons can be in a shell. First of all, let's label these shells. This is called the what shell? K, L, M, you know, and it goes on. K shell, L shell, M shell. Electrons live in the shells, and there's a limit to how many electrons can be in a shell. Here's your formula. You've seen this before? Is this a review? Is this a review?
I recall a little bit of chemistry, but that was a year and a half ago.
Chem 2 years ago, so
You took what?
Chem 2 years ago, it's kind of.
Okay. Review? No? No? All right. All right, so it's 2 times the number, or the number of the shell squared. So you see on the K shell is the what? First shell. Square 1. 1 times 2 is 2, right? All right, so there's 2 in the K shell. We good? So then how many in the L shell? Maximum. 8. All right, everybody agree? I don't want to put too many in.
Is there a maximum of 8 in all of them?
Pardon me?
Is there a maximum of 8 in all of them, all of the shells?
Except for the first one.
Except for the
Yeah.
ones. Okay.
And now this shell, M. How many can that have? It's a third
18.
squared 9, right? Times what? 2? 18 here, right? Just gonna be drawing these, you better stop me.
I don't know how to count.
Huh?
Something I
All right,
can
should
count.
we just put a, okay? You all know. All right?
So the 3 is a representative of how many shells from the outside we're at.
Yep, where we go from inside out.
Okay.
K is 1, L is 2, M is 3, and so forth.
When we did our chemistry though, it talked about there was a limitation, though, like you can only have 8 in each shell.
Yeah, but I've heard the 18 too, so.
Yeah,
I don't know.
I've heard it gets bigger, but type of thing.
Cause I remember having to do like a whole bunch, we
Okay.
had to find out the number of electrons and stuff, and we would do like an SPDF.
my point is, I want you to know this.
Oh,
I got you.
Okay? Let's leave it at that, and, look that up for me. Maximum. Where that up comes in, next class. All right, so these shells, these electrons, what kind of a charge do they have?
There you go.
They have a negative, what do the protons have?
Positive.
Neutrons?
No charge.
No charge? All right, let me give you the charge of an electron. It's negatively charged. And that is a charge of 0.000 548, and the unit is AMU. That is the definition of an electron. We good? All right, so these electrons, they spin on that orbit, that shell. To be stable, if one's spinning this way, there's one spinning. Yeah, can you do that? Everybody do this. Jake? And I'll go the other way. Can't do it.
no.
All right. Now. These electrons are held in place by something called kilielectron volt. Kilielectron volt. KEV. And it's the binding energy. That holds these electrons in place. The further you get away from the nucleus, the less they become lightly bound. Do you know what I mean by that? They're not held in place all the time. So electrons in the M shell are loosely bound, and electrons in the K shell are tightly bound. Did you guys talk about ionizing radiation? So you know what happens here, don't you?
Moving around of electrons from ionization.
Okay. Right? You guys covered that?
A little dusty on that, but yeah.
All right.
It's a long break.
All right. All right. So there's an atom, right? Forget where I put it. And a photon of radiation comes along and hits, let's say, this electron. It hits it dead on. What happens to the electron?
blast out.
It gets kicked out, right? So you have what out here? A free electron? This guy's gone now? What are we looking at?
Unbalanced atom.
Unstable atom.
Unstable.
It's also called an, all right. An ion pair with an unstable atom. That is what you're looking at. Ionization, right? What happens as a rule?
The electrons in the outer shell has to move in.
Yeah. This guy will move in, right? What happens when it goes from here to here? You know?
Energy is released.
It gives a wave, a photon. So it's still unstable. What happens here?
Picks one up from.
It picks one up from somewhere.
Some.
So anyway, so there's an electron out here from another interaction, and so what do we have now? Stable atom, right? Yeah. Okay. Ionization, the removal of an electron. Some people say the removal and addition. You can say that too. All right, a little bit on that. Okay, do y'all know what, well, we're gonna get there. Okay, now I think we can move into, so that was atomic theory with a little bit of ionization and let's talk about the periodic table.
What was the name of that formula for?
I'll look for it.
It helps for the name.
All right, so the periodic table is an organization of what?
Elements.
Elements. This is an organization of elements. Okay? And they're structured and classified by atomic number. Okay, you see the numbers? And, what does the atomic number mean?
Number of protons.
Where?
The nucleus.
Good. Atomic number is the number of protons in the nucleus. There's another unit, so that's called atomic number. That's how they're classified. There's something called mass number. What is mass number?
Number of protons and neutrons.
When you add here, guys. P plus N, it's mass number.
That's also the atomic weight, right?
Yes. Uh-huh.
You didn't need these back, did you?
No,
I've already
no.
started marking on them, so.
No, that's for you to write on. Again,
I just wanted
we
to
try
know.
not to pass. All right. All right, there's something that you'll need to know that comes along with this. It's something called an isotope. All right, I'm gonna leave that with you. You can Google it, look it up, get your hands around the concept of isotopes. Now, the periodic table, let's talk a little bit about the periodic table and elements, and how it kind of comes back to what we deal with radiation. So, what element do we use to protect people from radiation?
Lead.
Lead, right? Why? Look at it has what type of atomic number? Would you say it would be high or low?
I would say high.
Lead has a high atomic number. And you know, do you all know the term phenomena? What is that? How would you define phenomena?
Relatively unexplained.
Something that happens when we really can't explain it. I think it's a phenomena that the concept of lead and the fact that we have, do you know this term, polyenergetic beam? Have you heard that term? No? Okay, a polyenergetic beam of radiation has what type of energies?
Both.
Many, a lot of energies. So a polyenergetic beam can be absorbed, completely absorbed by what? Lead, okay? Because that's, I mean, you've all been to the dentist. What do they put on you when they do oral dental x-rays? Lead. You know, what else could you use? Look at the chart. What else could you use that has a nice high atomic number?
Pretty much anything after that, right?
Pardon me?
So pretty much anything after that?
Yeah. Like, is there something there that you know?
Radon?
No, radon's a gas.
Oh, yeah, you're right, sorry. I wasn't thinking. I just said the first thing I looked at.
Have you heard of radon gas?
Yeah.
Where?
Like mountains kind of.
Where?
Wasn't it in mountains?
Basements.
I remember somehow.
Comes from the Earth's crust.
Yeah.
Radon gas is a naturally occurring radioactive gas. So,
Shouldn't you check your homes for it?
where does, yeah, we'll talk about that. Where does radon gas come into play?
Like soil, doesn't it originate from soil? I mean.
You know, I asked a physicist about this at one time, you know. We don't have basements here, do we? But if you've ever lived up north, you know, people have what? Basements. And, you know, sometimes when you go to sell a house, you gotta have your basement checked out with a detector for radon gas. So they put a detector in. So I asked a physicist about this once. I said, where'd this all come? He said, well, first of all, radon gas has been around forever. And he said, the other thing is, he said, we can detect it much better today than ever. And, you know, you can all weigh in on this next one, and that is, homes are built stronger than ever. So what does it do? Keeps it in.
Oh, wow.
All right. So radon gas. But when you look at that periodic table, what else could we use instead of lead to protect people? Could we use gold? Huh? Could we use silver? All these things with high atomic number could be used instead of lead, but what's the up and the down here?
Expensive.
The cost. Can you imagine having a gold apron? Or a silver apron? lead is plentiful and it's cheaper, but they would all work, and I'll just give you an example. And as you go through making your presentations, you may look at some images and you might see the head with teeth, right? And what can you find in teeth? Yes, and that's in play. The composition of a tooth has a high atomic number, but it's the combination of a lot of things. But what do you find in teeth? Fillings, right? Fillings are what a lot of? Silver, all right? So when you look at silver, a filling in a tooth, and you may see this now as you go about your present, it's the same as lead. It's a high atomic number. It gives the same appearance on an image, right? It does what? Absorbs radiation. Okay? So yeah, just a little side story on that. All righty, that's what I wanted to cover today. Does anybody have any questions? Get your hands around isotope.
So the difference between an isotope and a radioisotope is an isotope just becomes unstable.
Yeah, they can take, there are a radioactive isotope. Okay, get your hands around what an isotope is. A radioactive isotope gives off radiation. That can be manufactured in a lab. Okay? And who has nuclear medicine? Yeah. They get radioactive isotopes. Okay, and you'll notice too about an isotope that's radioactive. Over time, it weakens. Okay? Gives off its radiation. And as it's given off its radiation, the composition changes because things change atomically and it decomposes to another material. Okay? That's a radioactive isotope. They make that in labs. When you ship it, it's got to be encased in lead. You got to get it there by a certain time because you need the strength. And, just another little thing for nuclear medicine, when somebody is getting a nuclear medicine scan, they get an injection or they take orally radioactive material that gives off radiation. How do we detect it? Bless you. Okay? They put something over the patient, like if we're doing a liver scan, they'll put a device over the liver. So let's follow the lead here now. It's called a gamma camera because the liver is radioactive now, giving off
Radiation.
what kind? Gamma. The gamma camera detects the gamma radiation. And here it goes back to what we said earlier about change in energy. Okay, now it's a photon hitting the gamma camera, and then it's processed electronically, numerous forms of energy, and in the end, what do we get?
An image.
An image. Okay, an image. So that's where I want to end today. We're going to come back next week and talk more about radiation and its characteristics. And then we'll review for the exam, okay? So this is early. You can do your research, okay? Don't procrastinate. It's the 12th of January. Make a New Year's resolution to not procrastinate.